In this question, he is asking that the area of the polygon whose vertices are the non-real roots of the equation z bar equal to I z square is. First of all, I will use this concept that if z1 is equal to z2, this implies that mod of z1 is sure to be equal to mod of z2. But mod of z1 is equal to mod of z2 doesn't surely mean that z1 is equal to z2. Keeping this thing in mind, given z bar is equal to I z square implies that mod of z bar is equal to mod of I z square. That is, mod of z is equal to mod of I into mod of z square. Mod of I is 1. This implies that mod of z square is equal to mod z. This implies that mod z is equal to 0 or mod z equal to 1. If mod z equal to 0, then it surely means that z equal to 0, and z equal to 0 clearly satisfies this. But if mod z equal to 1, then we have got the information that distance of z from origin is 1. But it is not that all the complex numbers lying on a circle with center 0, 0, radius 1, it's not that all these points will satisfy this equation. So far I have got the information that the numbers which will satisfy this equation will lie on this circle, and other one more possible answer is origin. Hence, if mod z equal to 1, then I can say z equal to e to the power I theta. This means e to the power minus I theta is equal to I into e to the power 2I theta. That is e to the power 3I theta is minus I. That is cos 3 theta plus I sin 3 theta is 0 minus I. Means cos 3 theta equal to 0 and sin 3 theta equal to minus 1. Note that if cos 3 theta is 0, then sin 3 theta can be 1 or minus 1. But if sin 3 theta is minus 1, then cos 3 theta is sure to be 0. Hence, the values of theta which will satisfy both these equations will be obtained by solving this equation. That is, theta is equal to 2n pi minus pi by 2. And keeping in mind that theta lies between minus pi and pi, I'll find all possible values of theta. Note that if I go beyond pi or I go less than minus pi, I will start getting the same values only if I take theta lying between minus pi and pi. That is, theta I have got is 2n pi by 3 minus pi by 6. If I take n equal to 0, I get theta equal to minus pi by 6. If I take n equal to 1, then I will get pi by 2. If I take n equal to 2, then I will be getting 7 pi by 6, rejecting it because it is beyond pi. If I take n equal to minus 1, then I will get answer minus 5 pi by 6. Hence, I will be taking only these three values of theta and get three possible values of z Note that z equal 0 will be rejected because he has clearly told us that the vertices are non-zero real roots of this equation. Because it is given that vertices are non-real roots of the equation this. And hence we have got a triangle A, B, C, e to power minus I pi by 6, e to power I pi by 2 and e to power minus 5 pi by 6. There is a complex number. There is a complex number of A is cos pi by 6 minus I sin pi by 6 equal to root 3 by 2 minus 1 by 2 I. B is equal to cos minus 5 by 6 plus I sin minus 5 pi by 6. That is minus root 3 by 2 minus 1 by 2 I. And C is from here 0 plus I. By symmetry of the complex numbers of A, B and C, it is easy to see that A, B, C are at the positions as below. C will be here, A will be root 3 by 2 comma minus 1 by 2 I, that is root 3 by 2 minus I by 2, and here minus root 3 by 2 comma minus I by 2. Suppose this point is D. Clearly area is 1 by 2 into CD into AB, that is 1 by 2 into 1 plus 1 by 2, because this length is 1 and this length is 1 by 2, into this length is 2 into root 3 by 2, that is I get 1 by 2 into 3 by 2 into root 3, that is 3 root 3 by 4 is the area of this triangle. Hence I can say A is the correct choice. In this question it is given that let A equal to the set of complex numbers satisfying this condition, B equal to the set of complex numbers satisfying this equation, then A intersection B, that is you have to find all the complex numbers which satisfy this condition and this condition both. These are the choices. First of all, we'll see that this inequation represent what, and then I will explain the locus of this equation. It is clear that this means mod of z plus 1 upon z minus 1 is less than 1. That is mod of z minus 1 is less than mod of z minus 1. That is, I can say z is a complex number such that its distance from minus 1 is less than its distance from 1. That is, in complex plane, I will say if minus 1 is here, 1 is here, the complex numbers lying on this side of y-axis. Note that this point is midpoint of A and B. All the complex numbers lying on this side of y-axis will satisfy this inequation, because for any of the points on this side, this distance is less than this distance if this is the point P. That is, I can say set A is the complex numbers of all these points on left hand side of y-axis. Not even the points on y-axis will satisfy this equation because lesson is there. And to understand the other part, first of all, let me explain you this concept that suppose these are the two lines and point of intersection has affix z1. This point has affix z2. This is the point having affix z3 and this angle is theta. Suppose you have to find the angle theta. Then for finding the value of theta, first of all mark anti-clockwise direction in the angle. Then I will say theta is equal to argument of, say this is a point A, this is a point B, this is a point C, and this is AB vector, this is AC vector. Note that the vector from where the angle is starting, that vector is to be written in the denominator. The vector where the angle is ending, that vector is to be written in the numerator, and this is equal to theta. That is, I can say theta is equal to argument of, here z2 minus z1 will be written here, z3 minus z1 will be written, because this means complex number of C minus complex number of A, and this means complex number of B minus complex number of A. And in case if this direction is clockwise, then the value of angle will be negative. Now argument of z minus 1 upon z plus 1 is equal to 2 pi by 3. This implies that argument of AP vector BP vector is equal to 2 pi by 3, and in complex plane, this is the point A having complex number 1, this is the point B having complex number minus 1, and this is the point P having complex number Z, and AP vector is in this direction, BP is in this direction, and according to the formula I just now told, this means angle has to start from BP vector and go up to AP vector, and the direction should be anti-clockwise. It is BP, this direction is anti-clockwise. This is correct diagram, but had I taken the point P below, then that would be wrong diagram, because in that case angle would start from BP and go up to AP, and this direction would have become clockwise. Had it been minus 2 pi by 3, the point P would have lied below x-axis. And because the angle is fixed, it means locus of the point P will be a circle. And that will not be a complete circle, because 2 by 3 angle is obtuse. Actually, this will be a part of this circle, but these points will not be satisfying this equation. Only these are the points which will be considered as solution of this equation. Yes, this would be minor arc of the circle, this would have been major arc of the circle, because this angle is obtuse. Hence, to satisfy this equation, the complex number should be lying on this arc of the circle, excluding the points A and B. And just now I had proved that The set A represents set of all complex numbers lying on left side of y-axis. Hence, the complex numbers satisfying both the conditions are these, excluding this point and this point both, because the points were lying on left hand side of y-axis. And because in the choices he has spoken about the center of the circle also, it's not difficult to find the center of the circle. And to find the center of the circle, it is clear that because this angle is 2 pi by 3, if this is the center, note that this is the minor arc. This angle would have become 4 pi by 3. 4 pi by 3 means this is 2 pi by 3. That is, this is pi by 3. That is, this length would have become 1 cot pi by 3 with negative sign. That is minus 1 by root 3. Hence, we have concluded that the portion of circle lying in second quadrant and with 0 comma minus 1 by 3 as center of the circle, that is these points, will satisfy both the conditions. Hence I can say B is the correct choice.